Hey, this is Horner, and this is the second part of the constant velocity motion problem exercises. This will be number 5 through number 8. And during the Apollo moon landing, they put reflecting panels on the moon, and this allows anybody on Earth. So here's Earth, and if you are standing on Earth, so there you are, and there's your arms, and you take a laser and you shine a laser beam at those panels, they will hit the panels on the moon, and then that light will come back. And we are able to time it. We find out that it takes 2.52 seconds for it to go all the way there and then come back. So let's try to figure out how long it takes for it just to get there. If the entire trip is 2.52 seconds, I only want to know half of that trip. We're going to divide by 2. So the time to just go in one direction is equal to 1.26 seconds. So that's to go from Earth to the moon. And that's really what we want. If we use the 2.52 to do this calculation, the distance would be twice as far as what the moon really is. So that's the deal with this one. You have to be just really careful. All right, so now that we have a time, we also have a speed of light. So to find that distance, we're going to use the average speed. So we're going to say, oops, sorry about that. We're going to use speed average is equal to the path length, which is the same thing as the distance, and we're going to divide that by the time. So if we want distance, we can just multiply both sides by time. So now I can say distance is equal to the average speed times time. All right, now the time for this one is in scientific notation. So you see that it's 3 times 10 to the 8th meters per second. And we want to multiply that times the 1.26 seconds. So to help you with this, I actually have the calculator app. So let's go ahead and bring up the calculator. Here's our calculator. This is a graphing calculator, but a lot of calculators are very similar to this. If I want to type in the 3 times 10 to the 8th, I'm not going to say 3x 10 caret top 8. Instead, I want to type in 3, and then I'm going to do second, and then I'm going to hit this key. And when I do that, you'll see an EE there. That EE will show up as an E. That means times 10. So if I come back down here, when I put it in the calculator, I'm going to say 3EE 8. That means 3 times 10 to the 8th. Some calculators have an EXP key on it. It means the same thing. So you could either type in 3EE8 or 3EXP8. If your calculator doesn't do either of those, let me know, and I will help you with your calculator to get it to work right. So once I have that 3 times 10 to the 8th in, I'm going to multiply it times 1.26, and I should get my answer. And my answer here is going to be, so I'm going to go ahead and let's pull up that calculator again so that we can do it. So we've got 3 times 10 to the 8th, so I've put it in, times 1.26, and here I end up with an answer of 3 and then 780,000,000. So if you start at the very end here and you count back 3, count back, there's 6, 7, 8. You want one number left of the decimal, so I'm going to put 3.78. So this final answer is 3.78 times 10 to the 8th, and then it would be meters. So the only tricky part on this one is recognizing this is in scientific notation and then using your calculator correctly to do that. Next question. Hans stands at the rim of the Grand Canyon and yodels down to the bottom. So here's the Grand Canyon. Here's Hans standing at the top. He hears his yodel echo back from the canyon floor 5.21 seconds later. So he screams down, and then it hits the floor, and it comes back up, and he hears it. So the total time, so here's time total, going back from the top all the way down and then echoing back, is equal to 5.20 seconds. Remember, this is total time. It's not time just for it to go straight down. They want us to find out how deep the canyon is. So to do that, I only want the time to move all the way down. So we're going to call it T1. So T1 here is equal to 5.2 divided by 2. So if I take 5.2, and divide it by 2, I end up with 2.6 seconds, and that's the time to just go from the top down to the bottom, and that's really what I want. The next thing I need to do is I have to figure out what is the depth of the canyon. So I need to say what is my change in position. But because it says speed of sound, we can actually use our speed equation. So let's not use the velocity equation. Instead, let's just say that speed average is equal to, and then we have the distance, okay, divided by the time. So what we're going to do now is go ahead, and since we want to find out how deep the canyon is, we're going to say the distance is equal to the speed times the time, and that's average speed. So the average speed of sound and air is 340, and then we want to multiply that times 2.6 seconds. And if you do that, you do end up with 884 meters. The other way to do this problem is to use the 5.2 seconds, and then you're going to get a number when you divide it. It will then end up being 884 meters. So you can do it either way. I like to go ahead and divide the time first. That makes it a little bit easier. For number 7, Destiny completes a lab in the physics room. She starts a bowling ball to the left end of a meter stick. So here we've got 0, okay, and we've got a meter stick right here. In fact, we have several of them. But to the left of that meter stick is the position -0.23, and that is where she starts the bowling ball. Then the bowling ball rolls and it goes all the way down here until it gets to 3.35 meters. It takes a certain amount of time for it to do that, and it's traveling at this velocity. So this is our average velocity. They wanted just to figure out how long it takes to get there. So here we go. We're going to say the final position is equal to the velocity times the change in time plus the original or initial position. Our final position is 3.35. That's equal to our velocity, which we said was 2.15, times the time, that's what we're looking for, plus -0.23. We're going to take 3.35, we're going to add 0.23 to both sides, plus 0.23, and 5 plus 3 is 8, this would be 5, and so this is 3.58 is equal to 2.15 times the time. To divide both sides by 2.15, and when we do that, we end up with our time, and our time here is equal to 1.67 seconds is how long it takes to roll from this position all the way over to the ending position of 3.35. Finally, let's take a look at number 8. This is about a peregrine falcon. It's the world's fastest known bird, and it's been clocked with a vertical velocity of 97.2 meters per second. So that means it's moving in this direction. What we'll do is over here, we're going to make, well, we're going to get rid of that first. We're going to make something, oops, it's just going to keep doing that, isn't it? We're going to make a dot, and then we're going to say up is positive, and on this dot we're going to say down is negative. And because this bird is moving down, and we've said that moving down is negative, we'll say that the velocity of the bird here is negative 97.2 meters per second. Since it is a vertical velocity, it can have a direction, and we're going to make the direction down negative. You could also have made this positive and made up negative, as long as you just stick with whatever you do. Next thing we'll do is we're going to say that it's traveling straight down, and we know that it's starting at a height of 100 meters. So our initial position here is 100 meters. Let's go ahead and use our equation. The final height is equal to the velocity times the change in time plus our initial height. Our final height would be the ground, so we know that that's 0 meters. That would be equal to our velocity, which we said is negative 97.2, and then we're going to multiply that times our change in time. To that, we're going to add 100 meters. Now, if I subtract 100 from each side, I'm going to end up with negative 100 is equal to negative 97.2, and that's good because we can't have time. We don't want time to be negative, so this keeps that from happening. Our final time then it takes for the falcon to descend is 1.03 seconds, and that is the amount of time it gives the rabbit below to get out of the way. So not very much time. And that is number 8. Next video, we'll cover the next